we have a single element plus a compound, which is how we know this is going to be a single replacement reaction. Anytime you have a single replacement reaction, you have to use what's called an activity series to determine will the reaction even occur. We're going to compare aluminum and silver. So here is aluminum and here is silver down here at the bottom. So because aluminum is at the top, it's going to get a smiley face, and silver is lower on the list, so it's going to get a frowny face. So we're going to have a smile for aluminum, a frown for silver, and we'll arbitrarily give bromide a little ring. Now, anytime you have a sad couple, it's going to have a replacement. So the aluminum and the silver are going to switch spots. So I'm going to put silver in place of aluminum. It's going to be alone, so my lonely frowny face. Plus, I'm going to put aluminum in place of the silver. That's my smiley face. And I'm going to put the bromide, or leave the bromide right where it is. And that's going to be my little ring. So now we have a happy couple paired up. Anytime you have a single element, you're going to want to check to make sure, is it one of the 7 diatomics? It is not, so it does not need a little 2 subscript. And anytime you form a new compound, you have to verify the charges and balance them. Aluminum has a +3 charge, and the bromide has a -1 charge. Therefore, +3 versus -1, we're going to need 3 bromides, because 3 times 1 equals -3, to balance with the +3 on the aluminum. Finally, I can balance the coefficients for each of these. We're going to have 1 aluminum, 1 silver, 1 silver, 1 bromide, 3 bromides. Means I'm going to need to fix it by putting a 3 here, because that's going to give me 3 bromides to match these. My silver has been modified. I now have 3 silver, so I'm going to need a 3 here. And now to finish it, 1 aluminum on both sides, 3 silvers, and then 3 bromides. Final answer is aluminum plus 3 silver bromides yields 3 silvers and 1 aluminum bromide.